There we go. All right, let me just get back to the webcam here. All right, so we should be recording now, and so yeah, if and Robert mentioned he's hearing it now, but I will be posting recordings to all of the meetups. So if you're unable to make it one week and you want to, or if you want to review content, you'll be able to just access that, and I'll put that in the meetup section of Blackboard. So yeah, once again, nice to meet you guys, and I'll shut this off now, but I'll get back to, oh, hold on one second. There we go, that should be off. All right, and is everyone seeing my screen? Cool, perfect. So let's just get to full. There we go. Let me get this out of the way. All right, so we'll go through a couple of slides. Let me just get the chat up here. So if anyone has any questions, I have the chat open here, so feel free to enter it into the chat. Also, obviously, if you have your microphone on, feel free to just ask away. So welcome to our first lecture. It's just a little introduction of myself. So I work as an application engineer at Plotly. Basically, am the application engineering team at Plotly. We're a small startup based in Montreal. And this is just an example of a couple of other places I've been successfully, what else I like to do in terms of in the data science world. So I was previously working at IHS, and if you guys, anyone in economics who have come across eViews, you have, that was it's an econometric package. IHS was an economic forecasting company, and I sort of handled the working with clients using our econometric packages there. Similarly, I'm sort of the client-facing engineer for Plotly. So basically, my professional history has been working with people who are using data science tools. So I sort of take that angle of looking at the tools that you guys will be using. I'm not based in Montreal. I'm actually based in New York, and most of the team is based in Montreal. So just a quick, let me put this here. So just a quick intro to what this class is going to be about. It's basically, just sort of getting more and more into detail in terms of what we're working with here, but it's just about presenting, presenting information and how to, presenting quantitative information and how to use technology to that end. So this is going to be focusing mainly on the tools that you guys have been learning in your classes so far. In the introductions, it seemed like many of you were sort of around your fifth semester. So, sort of second year around roundabouts. Is this sort of anyone's like, maybe third class or anyone sort of earlier in the program? All right. Okay, so we have a couple of people who are, fifth class, okay. Yeah, so in terms of what this, like you have other classes, particularly 607 and 602. I know officially it's listed as 602 being the prerequisite for this, but I would also say that 607, it's very useful, especially since that's going more into working with R and kind of introducing you guys to the ETL workflow. And in terms of just what you guys have installed, I assume all of you guys have RStudio installed and have been working with that. If anyone hasn't, feel free to, cool. Yeah, and if anyone doesn't, leave it in the chat or feel free to email me separately and we could get you up to speed. But pretty much just be working from that starting point. And then just sort of general class info. The class dates are all in the syllabus, and actually the meetup info, I would use that because I believe there was a spring break that sort of pushes everything off towards the end of the semester. So trust the dates in the meetup info. And the way that this is structured is every other week. So basically, every week where there is a class, homework will be due on that Sunday, and it'll be Sunday at midnight. And at the end of the semester, you will complete a larger final project. So I'll post info for that later this week. But it's basically going to be very open-ended. You'll be able to pick a data set of your choice, pick a visualization challenge of your choice, and it's essentially just going to be visualizing a data set of your choice, and it's going to be an interactive visualization. Like we're starting out using more sort of just exploratory data analysis in R, but we're going to be moving on to more strategies on doing interactive data visualization. So you will be expected to include some interactivity in your visualization. And I also have a link to the course GitHub page. In terms of just where to look for things, I know a lot of instructors, they'll use different places to post things. I'm sure some have mentioned how Blackboard isn't the best environment to use, but I'll be mainly focusing on Blackboard just because that'll be kind of the record of the course. So, basically that's sort of what I'm using as kind of the final word in terms of where things will be posted there. But, feel free to use the GitHub, or everything will be posted there as well. Just keep that in mind. And yeah, then I mentioned GitHub here. Yep, we will be touching on Shiny apps. We actually will be going through, so in terms of, from the R side, we'll be going through Shiny, Python. It's mainly going to be sort of like using Matplotlib and the visualization libraries there. So in terms of interactions, it's going to be not just sort of the base Plotly interaction. So if you just create a line graph, you have hover interactivity. It'll be sort of more towards either creating a Shiny app or using D3, where you pretty much are able to do whatever JavaScript allows you to do. We're not going to be covering Tableau in this class. So Tableau is desktop based. That's made for and we're really focusing on tools that are going to augment what you guys are already learning. So you guys are getting familiar with data science programming languages. So we'll be focusing on sort of that end of visualization. So unless anyone has any other questions, just get into the content here. So just for the first example, does anyone recognize this photo? Yep, that's correct. This is the Challenger disaster, and and there's actually an interesting lesson to learn here in terms of data visualization. So basically, these pictures they show kind of the what led to the explosion, and you could see the arrow is pointing to where there was a fuel leak. So it's in sort of the booster rockets, and you could see kind of what ended up happening there. That sort of ended up leaking onto the fire, and that's what caused the disaster to occur. And in terms of what the engineers were using as a guide to, they had historical, rocket tests. They had some data to go on in terms um, of the safety of these rockets. And this is sort of one of the main visualizations that they were using for finding out like when under what circumstances damage occurs. So here you could see that the way that they're displaying information, you have these are sort of rocket tests. So there's two booster rockets that they're showing here for each kind of trial. And you could see these marks here that are showing the where damage occurred and marking so in some cases you'll see multiple sort of damage markers, and each of these lines there are gaskets that are called O-rings. So in terms of just looking at this visualization here, does anyone is there any sort of pattern that kind of emerges for anyone? Like if you were looking at this, do you think, is there any sort of conclusion that you would be able to draw from something like this? I forgot to mention, by the way, the in the upper left hand side, you could see the temperature that was outside. So this is mainly looking at the how what sort of damage occurs depending on the temperature. Is anything jumping out to anyone? That's kind of good that no one saw anything because this is, it is kind of hard to really parse out any meaning from something like this. You have you could try to remember what the temperatures are, try to sort of hold in your head like what conclusions you could draw. So maybe one thing that you could see is just looking at where they're first of all trying to separate out where there was damage. So here there was damage. It was 70 degrees. Here it was 57 degrees. So here you could maybe get an idea like this is 58 degrees and there was damage. You have a couple of like 70s and 80s and there's no damage. So you could kind of get an idea of what's going on, but it's by no means clear in terms of what's really happening. And so I accidentally showed this, but this is an alternative way of looking at these of looking at how damage is occurring. So each of these points represent one of these cases here, and what they're just showing is the number of failures. So you could see all of the cases where there's no failures. When you're up in this temperature range, there's some sort of low number of failures happening over here. And then you kind of see this visual pattern happening here where temperatures as they get lower, there's more of a certainty that at least there's going to be some failures. And something like this, it's not really going to show up in the in terms of statistics because these would almost sort of be seen as outliers. But definitely, you could see that if you saw this graph, it's giving you a lot more information than if you saw something like this. And right here in particular, this is where it happened to be a pretty cold day. This is especially considering this is Cape Canaveral, so this is Florida temperatures. And so definitely looking at this graph and seeing where what the temperature was that day, if you saw a visualization like this, definitely would kind of provide more information and make people a bit more concerned about scheduling the launch that day. So this is just an example of some other bad visualizations. So kind of going through these with something like this, does anyone know why this is the time series here? Why this is a bad visualization? Could almost Exactly. So I was about to say, like, you could almost sort of look at that from the reverse perspective when you're trying to, look at these visualizations. Try to think like, what are you getting out of the visualization? Is there, do you see what the creator's point was in creating this? So, Keith, you're absolutely right that this is just simply too busy. You have too much variation. Um, if you have something spiky like this, it would probably make more sense to break apart the traces. And then you could just see a couple of other, some of these are just horrendous. So you have a pie chart that's not even adding up to 100. You have, this is just kind of a non-traditional visualization, but it's unclear really what it's showing. Like what it should be showing is how there's sort of different usage patterns of electric vehicles versus when they would be charged. So this is sort of meant to be a 24-hour day and looking at variation in that day, but it's not really getting that point across. And then for something like this, when you're looking at the warmest year on record, it's kind of obvious that the scale is a bit off. So it's definitely climate change to worry about, but 2012 wasn't twice as hot as 1998. So you could see the numbers on top of the bars that are showing what's happening here. So these are sort of mixes of either bad choices or just kind of misleading in general. So in terms of the goals of data visualization, really what it's about is you have obviously we're dealing with larger and larger data sets. And even with small data sets, it's better. The human mind simply comprehends pictures better than looking at a table. So you really want to just get your point across in with minimal effort. So have someone be able to look at your visualization and see like this is the point that I'm trying to get across, and have them able to retrieve that, retain it, and really get to that insight quickly. So these are a couple of strategies that we're going to be using. So in terms of just general practice in building visualizations. A lot of these strategies, they come from, has anyone heard of Edward Tufte? Yep. So I see we have some people have, some people haven't. He has a series of books that really are kind of classic standards of data visualization. Make excellent coffee table books. They're just kind of very compelling, and so a lot of these kinds of strategies, they come from insights of his initially. So really, what you're trying to do is, this is really in line with the goals that we set forth over here, where you want to be able to match the display of data and purpose, maximizing the information to ink ratio. That's kind of tying to what we had here about, minimizing mental effort. You want to be efficient in your visualizations, and we'll get into the principle of small multiples, but that's a specific strategy that I believe originated with Tufte. So here you could see different types of data. So I ended up posting Tamara Musner's speech. Here you could see the next couple of slides are coming from her. So it's nice just to sort of look through her slides to get an idea of kind of the way she's presenting data visualization. But in terms of and this is sort of good for data analysis in general, where you're looking at different types of data. So the first two we're not going to be working with that much. I'll try to sort of provide you some tools to do maps, but we'll mainly be focusing on, we'll get to tabular data, but just to sort of introduce the first two, relational data is, really kind of links between points. So you could think of these as like social networks, the examples that I gave here, family trees, international trade. Actually, this tree right here, this is relational data. So you could see that it has kind of a branch-like structure. And then spatial data is sort of intrinsic position. So it could look similar to other data points. So, you're looking at, if you're looking at dots on a map, for example, it's, that's very similar to sort of looking at X, Y, longitude and latitude. But what really matters with spatial data is it's its intrinsic position. So it's, sort of a general point in space. And what we're going to be working with mainly is tabular data. So, and here there are some more divisions in terms of the data types of data that we have here. And you could kind of think of this as sort of, different ways of classifying your data. So, with tabular data, a lot of times you'll have mixes of these types of data. And as we go into sort of, mapping ways of mapping variables, you'll sort of see this in action. So you could imagine that you could have data that's categorical, that some variables are also discrete and continuous. And just in terms of what these mean, so you have ordered and categorical. Categorical meaning it's sort of discrete. There's not, and in particular, not an order to them. So things like different types of fruit, for example. There's no sort of ranking there, and that's sort of versus something that's ordered and discrete. So small, medium, large, extra large, like that's comparable to categorical data because it's discrete, but there's a ranking there. So that's sort of one thing to consider that those two can sometimes be related. And lastly, continuous. That's sort of what you usually think of with quantitative data. So whenever you have you're measuring pounds, you're measuring weight, you're measuring anything that you're measuring really, and you're able to kind of directly compare the value of is something that could be considered continuous. So any questions on that before we move on? All right. So here, this is going to be about sort of mapping, mapping the display to your different types of data. So spatial, that's the easiest one. Those are maps. You have, you're mapping out longitude and latitude. You have obviously something that you're sort of mapping to. So you can imagine this being, um, sort of globes, maps. Even if you're looking at the positions of stars, that's sort of a type of spatial data. And when we get into relational data, you could see just different ways of dealing with this kind of data. So out of these, can anyone point out which one we used to show the different types of data? Like I mentioned, that was relational. Which one of these do you think we were using there? So that was just using yep, it was relational, but the particular type of display that we were using was connecting. So that's one of the strategies in terms of showing relational data. And as so something like that, you could picture a family tree that's kind of similar to connecting. The number one in terms of relational, contain, and these are coming from Munsner's talk, and she her research sort of deals with how the brain, like sort of almost on a neurological level, how the brain processes these different relationships. So this is based off of kind of when you see something, what's the best way to like at a base level, what's the best way to sort of convey that relationship. And contain, in this case, you could sort of think of as Venn diagrams. So, and in this point, it's just really a couple of points that are contained in a box. You could sort of think of like, in group versus out group. You could picture two groups. You're looking at the intersection of them, and really, if you have something like that, a Venn diagram is the perfect way to do that. And then just a couple of other ways of dealing with the relational data, so similarity and proximity. In terms of ordered data, you could see, again, ranked in terms of how these are understood. So things like position, length, area, shade, and saturation. And I'll get into in a bit the reasoning behind especially looking at things like length versus area or position versus length, like position versus area. There are some insights why position is better than area here. And then categorical, again, position is very good at kind of showing categorical data, but could also see a lot of common ways of dealing with this sort of data. So, color and shape, for example. And so, looking at something like this, you could see, how, like what you're looking at here. So you have your, kind of your most important variable. You have housing prices. You're looking at city. So that's sort of done using position, and then looking at time as well on the x-axis. And so this is going to relate to the discussion question that I posed this week. So has anyone had a chance to check that out? And was anyone did anyone think it was everyone understand what was being asked there? Okay. All right. So okay, that must have been Robert. That must have been recently because I don't think I saw um, I saw that. But in terms of and first of all, in terms of the discussion, it's meant to be more casual. So I kind of, there is sort of a task associated with it, but it's meant more for the discussion rather than, sort of being looked at as a traditional assignment. So that's just something to keep in mind. Like it's sort of um, more about learning in that way. So what I was trying to get at with the grammar of graphics and relating it to this sort of sort of the mapping of variables is really getting to kind of the core of what kind of what standards ggplot is created for. So that's really what we're working with first in R. Um, so one way that I like to kind of think of, looking at a graph and trying to, sort of almost back into the grammar of it is to try to think about uh, what sort of data this graph is coming from. So I accidentally moved to that slide, but hopefully that was quick enough. Um, so if you were to, sort of imagine what kind of table this data came from, what would you guys imagine? Yep, yep, Valerie, that's exactly right. So it's exactly. So that and really, it's like what I think is key is kind of thinking of it as like house prices by city by year. So you sort of think of the data in that way. So that's really what this is coming from. You could think of there being classification of data. You have your price, you have your date, and if you're thinking of this in terms of something like ggplot, um, you have your map. You bring in your data and you're mapping your aesthetics. So here we have just x equals date, y equals price, and color equals city. And that AES, like that's really what where what's being referred to when you're talking about grammar. And what I was trying to get at with the discussion board is trying to sort of expand that concept. So with ggplot, if you read through as you begin working with ggplot and you see how visualizations are made, you'll see a lot of how this can be used to create different types of graphs, and it's all very very similar in terms of if you have your x y, if you have some sort of uh, other types of variables that you're mapping to, like size if you're making a bubble chart, color if you're sort of dividing categorically, or if you have a continuous variable mapped to color. Um, so you can sort of think of kind of backing into that grammar in that way. So I'll just go to another example. So can everyone see this example here? Cool. So now here we added some interactivity. So similarly to, so here there's a bit different, things that we're looking at here. So we're picking the city from a drop down here instead of being showed in the legend. So just looking at this right now, if you got, and then just to clarify, SA means seasonally adjusted, and SA means not seasonally adjusted. So these are just two different ways of looking at the data. So if you were to look at something like this, how would you imagine this data being structured? So I guess to start out, it's so yep. So this is housing prices again. I didn't label my axes, but this is looking at time. This is the housing price index. So yeah, three categories of value by year. Tom, that's the best way of putting it. So and yep, Shyam, that's exactly right. So you have essentially you have different ways of classifying that data. And I mentioned in the discussion that you have sort of, ggplot is kind of reaching this. So there's ggAnimate, which is a package that is kind of expanding the grammar of graphics to look at animation a uh, as a variable. So this is an example of that where this is the Gapminder data viz. Have any of you guys come across this? Yep, it's an awesome TED talk. And this is, yeah, Hans Rosling is a great speaker. And, really, this was sort of the first time that uh, like for the time, this was like these are now starting to become standard, but for the time, this was, really kind of revolutionary in terms of data visualization, like really using the technology to its fullest at that time. So, the way that you could look at something like this is it's again, very it sort of reduces into a pretty straightforward tabular structure. You have your in this case time is being animated. You have life expectancy by GDP per capita, and then you have several other variables mapped. So size is mapped to population, color is mapped to continent, and each one of these points represents a country. So those are sort of your individual records. So for the discussion board, that's what I was getting at um, in terms of doing that. And let me get back to the slides. So what I provided in the discussion board were just links to a couple of other visualizations, and I wanted to kind of get you guys thinking about how this could work, and perhaps at what times may it not work. Something like ggplot, you could sort of think of it as an opinionated library where it really fits in nicely with certain data types, but can sometimes, if you want to be more free in the sort of visualizations that you're making, that might sort of that ease of use for tabular data might come at a hindrance to other sorts of visualization tasks. So, any other questions there? And so yeah, in terms of for this is just the structure of the data that's coming from uh, the other housing price visualization I showed you guys. Cool. So now this is sort of moving towards the other principles of visualization that we mentioned. So in terms of maximizing information to ink ratio, um, in I'm blanking on the exact title of it now, but in Tufte's book, it's he has a really cool sort of exercise of going through this, and you can almost think of it as when you're looking at a graph, think about what you could remove and still have the visualization make sense. So you could you could imagine these line graphs, and even in well, I'll get back to this example here, like even in an example like this, you could imagine things like these grid lines. I could remove those, and you could still, kind of imagine what this would be. So really, what this is, I almost never use PowerPoint. So the logical kind of endpoint of this sort of maximization of information to ink ratio is spark lines. So here, these are very kind of pared down visualizations. You really just have your date range. You have kind of a bare bare bones look at what your value scale is. In this case, these are labeling the endpoint, but it's meant to be kind of very bare bones, kind of giving you the information kind of in the most efficient way possible. And what this also leads to is the principle of small multiples. So in this case, we're looking at kind of comparing different measures. And in this case, you're looking at these different stock prices next to each other. So in looking at something like this, if we were to kind of apply the kind of backing into the data structure, the grammar of graphics. Yep, Tom. So this is so the reason why they're separated is because they are on different scales. You can imagine, like, if you had all of these stocks on the same graph. Here Apple is priced at around 500, BlackBerry is at 8.2, and what you're if you're graphing these on the same scale, this would just be kind of a line all the way at the bottom. And to address something like that, you also have sort of making sure that your measures are comparable. So over here, this is kind of what you would have to do if you wanted to compare two of these, for example, and you didn't want to make any changes to it. Naively, you may just have dual axes like this. But really, what's more correct to do is, and really what if you're looking at something like this, what a user would be more interested in is looking at the price change. So you're, here you don't have to worry about separating the axes. You're looking at the percent change, and you're able to kind of make a valid comparison. And then this is what something like this looks like in practice. So you could see how you have your sort of familiar Google Analytics visualizations here, and a couple different ways that it's used. So you could kind of see this in almost used like in here. You could see a lot of this looks like tabular format. So looking at something like this, you're able to very easily, can anyone pick out the outlier here? Yep, exactly. So it lets you pretty easily get at that, get to that point where you could see, a lot of these following the market, and PIMCO that's following bonds. So you're looking at a different measure. So here, I'm just reframing a couple of these visualization strategies, and I'll post a talk by someone named Scott Baronato, but he's another sort of another kind of more modern thinker on more recent thinker rather on data visualization. And a lot of the sorts of strategies that he focuses on, you could think of them as kind of just reframing of what someone like Tufte came up with when he wrote his books. So it's, a lot of the stuff, it's very like these concepts are they don't really change. There's new technologies, but really we have the same brain. So the way that he frames it is it's really informed by the point that you're trying to get across. And it's the way that I sort of think of it is it's kind of a conceptual version of maximize the information to ink ratio. So what we were looking at before, like maximizing the information to ink ratio, that's something that's very concrete. Looking at a visualization, trying to find out what you could pare down. Whereas with something like this, you're almost looking at your concept and thinking, what am I trying to get across? And what's the best way to do something like this? And he had an interesting, and the way that or sort of rule of thumb that I would apply to something like this is if you need to explain the mechanics of your chart, you're doing it wrong. So apparently I was doing it wrong with the housing price graph I showed you guys before. And the way that he sort of introduced this is in comparing the conveyance of information in text versus visualization. So if you're reading about statistics, that's kind of the worst way to really get to really like understand those numbers. You see the numbers, like all the information is there, but there's not sort of that immediate connection to what it means. You have to kind of parse that out. And so as an example, looking at this text here, cool, thanks. I just saw it in the chat. That's cool. So in terms of looking at something like this, and in a lot of like I know, especially in sort of I come from an economic background and economic research. You see all the time. You sort of create an economic model. You create you have your sort of thesis, and there's always something an article written up, and I don't think anyone actually reads those articles. Everyone's just looking at the data. They're doing, sort of their own, either drawing their own conclusions from the data or just looking at the graphs that are provided with the report. So for something like this, where, we're sort of comparing income growth across, rural, urban, suburban America, and you kind of get that from here, but it takes a while to get to that point. Whereas something like this, you almost immediately get that point. So something like this, it's giving the same information, giving those same statistics, but it's really presenting it in a way that gets the point across. And you could really see echoes of that. Minimizing ink to minimizing the ink that you're using to convey that information. So here, we're only looking at those two data points. That's the comparison that we're interested in. And in this case, it was pared down to just those two data points and kind of a version of small multiples. And just one kind of caveat he also goes into is, in terms of this is, you could almost think of this as related to something like this where context really matters. So for something like this, you could kind of see a story that's being told here about vinyl sales going up recently. Kind of think of that as like hipsters buying records, and looking at a graph like this tells one story. Looking at a graph like this tells another story. So really need to make sure that you're focusing on the right kind of frame. So one more kind of idea to go into, and this is getting back to what we were looking at with the Munzner slides, where you saw kind of rankings of the different ways of showing this sort of classifying this sort of information. This kind of gives the some of the research behind it. So what we're looking at here is just how the brain really interprets changes in these different types of stimuli. So for something like length, it's a one-to-one kind of mapping. So if something is twice as long as something else, you're perceiving that as twice as long, and so that's why that's a pretty good way of conveying information. And then something like area, for example, that only if something is twice as if something has twice the area of something else, the brain only perceives it as having sort of zero point 0.7 times the area. So when you're looking at that's something to keep in mind if you're looking at something like a pie chart, for example, and that's why I'll get into it in a bit, but why it's pie charts. Some people will say don't use pie charts at all, but it's sort of useful in only certain circumstances. And then on the other side, looking at something like electric current. So if there's uh, if you're being shocked with twice the voltage of if you receive two shocks, one is twice as big as the other, you're going to perceive that as 3.5 times. So I'm not really going to use that in data visualization, hopefully, but it's just another thing to keep in mind. And this is just kind of some more rules of thumb in terms of kind of general things that you'll come across through this course. So we're approaching the end here. Are there any other questions? Exactly, Tom. Hopefully, I'll help you. The previous slide. The previous slide. This is just kind of some rules of thumb uh, in terms of visualization types that you guys will come across. So if you are looking at pie charts, really it's keep it kind of around 3 or fewer. Usually where I find pie charts being their most kind of impactful is if you're kind of comparing, if you're comparing even two things, and you want to show, usually even I would say like it's best used if there's sort of a drastic difference, if you're, and you want to kind of show what precisely that means. But otherwise, if you have a pie chart with like 14 different slices, it's really hard to tell the difference between what's 5%, what's 3%, what's 20%, or well maybe not 20%, but it gets hard as the slices get smaller. And in terms of colors, it's this is just sort of in terms of when you're using when you're sort of categorizing data, and this is sort of and just saying not a scale, that's versus if it were mapped to continuous data. So if you're thinking of a choropleth map where maybe you're looking at states, and you're looking at some measure, so you're looking at population. Um, for something like that, it makes sense to have a single color scale, and you have kind of a range between light red and dark red, and you're sort of staying within that scale. In terms of categorical classification, it makes more sense to keep your colors distinct. So, like a rainbow, you could see the kind of different classifications there. And then the last one, that's just in terms of line charts. Don't make it too busy. So we're approaching the end here, and I also wanted to. These are a couple of the authors that were cited here, and just a couple of people to check out. So Jacques Bertin and Edward Tufte, they're sort of more pioneers in the field, and Tamara Munzner, she kind of goes into more the neurological research behind data visualization. And Mike Bostock is the creator of D3. So we'll be going into, sort of introducing D3 and how to kind of leverage the power of JavaScript to create interactive visualizations. So yeah, in terms of questions, especially about the assignment that's due on Sunday, does anyone have any questions about that or about anything else I went through? Yep, I'll take Robert's first. So in terms of the assignments, they're going to be every 2 weeks. So the first assignment it's going to be due on Sunday, and the next one is going to be due 2 weeks from Sunday. Our markdown would be fine if for this first assignment, if you're our markdown, like if you could format it in that way, that would be awesome. If you want to keep it in a script, that's fine too. So if you do our markdown, you could provide the just including the separate images as well. And then there was one other. Where'd my mouse go? How to adjust label on. Valerie, in terms of adjusting the label, are you talking about the axis labels or the position of the axis labels? Okay. Yeah, I actually don't know that off the top of my head, but Valerie, I'll send you an email. Or actually, what would be best is if you could ask that in the Ask the Instructor forum, and I could provide the answer there so that everyone could benefit from it. And then, what other questions were there? Yeah, R in Action. I don't think I came across that one, but the R cookbook is awesome, and the R graphics cookbook. Like those are very example driven, so it's really easy to just look at the different graph types and kind of it's framed in terms of like very scenario based. So those are definitely good under homework or ask instructor. Either one. I mean, both. Let's say under homework because this is related specifically to an assignment. Cool. So we're just over. So just get back on the webcam here. Is it okay if you post it? I wouldn't post that because part of the assignment is sorry, my computer's freezing for some reason. I hope my voice isn't freezing as well. So in terms of posting the code and pictures, I wouldn't do that because first of all, the code that obviously gives away, that'll give away too much. But in this case, even the pictures could, because part of the assignment is really like what type of visualization would be best. So I wouldn't go so far as to posting the picture, but If there are yeah, I don't want to discourage you guys from using the discussion boards, but obviously I don't want you guys to just kind of post answers there. So I guess if the picture isn't, if it's like an example picture, um, that and you don't think it gives away too much, then post that. And if it becomes an issue, I'll jump in and stop it. Cool. Anyone else have any questions? All right. So thank you all for attending, and I'll post the meetup in the meetup info session. So I'll just provide a link there. All right. Thanks a lot. Good night, guys.